Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Now make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have x to the power of x to the power of 2 is equal to 16. So I want to find the value of x here. For my solution, first start with x to the power of x to the power of 2 is equal to 16. Now I'm going to take the power of 2 on both sides. So now I have x to the power of x to the power of 2 to the power of 2 is equal to 16 to the power of 2. Important property of exponents is that if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And m and n, these two are interchangeable, meaning a to the power of m times n, this is the same thing as a to the power of n times m. So if a to the power of m times n is equal to a to the power of m to the power of n, then this means that a to the power of n times m, this is equal to a to the power of n to the power of n. So in simpler terms, a to the power of m to the power of n, this is equal to a to the power of n to the power of n. So right here we have x to the power of x to the power of 2 to the power of 2 is equal to 16 to the power of 2. So we can think of x to the power of 2 as m and 2 as n. So this is the same thing as a to the power of n to the power of m, meaning if we change these two places, it's going to equal x to the power of 2 to the power of x to the power of 2, which is equal to 16 to the power of 2. Now I'm going to let x to the power of 2 equal to the variable y. So now I have y to the power of y is equal to 16 to the power of 2. Now 16, this is the same thing as 4 to the power of 2. So now I have y to the power of y is equal to 4 to the power of 2 to the power of 2. Now if we go back, remember how if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 4 to the power of 2 to the power of 2 to the power of 2, that's going to equal 4 to the power of 2 times 2. And 2 times 2, that's equal to 4. So I have y to the power of y is equal to 4 to the power of 4. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, y is equal to 4. However, remember, we're solving for the value of x. So if x squared is equal to y and y equals 4, this means that x squared is equal to 4. So now to solve this, I'm going to take the square root on both sides. These two cancel out. Now I'm left with x is equal to positive or negative 2. So this is my answer. Alright, so I have 6 to the power of x is equal to 60. So the first thing I'm going to do is I'm going to rewrite 60 as 6 times 10. So now I have 6 to the power of x is equal to 6 times 10. Now I'm going to go ahead and divide both sides by 6. So then these two cancel out. Now I'm left with 6 to the power of x over 6 is equal to 10. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, 6 is the same thing as 6 to the power of 1. So I have 6 to the power of x over 6 to the power of 1, and if you divide these two, you get 6 to the power of x minus 1 is equal to 10. Now, if I take the log on both sides, I have log 6 to the power of x minus 1 is equal to log 10. So an important property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, log 6 to the power of x minus 1, I can move x minus 1 to the front. So this is going to equal x minus 1 times log 6, which is equal to log 10. Now, if I divide both sides by log 6, these two cancel out, and now I'm left with x minus 1 is equal to log 10 over log 6. Now I'm going to go ahead and add 1 on both sides. So these two cancel out. Now I'm left with x is equal to log 10 over log 6 plus 1. Now log 10, this is the same thing as 1. So now I have x is equal to 1 over log 6 plus 1. So log 6, this is equal to 0.7782. So if I replace 0.7782 with log 6, I get x equals 1 over 0.7782 plus 1. Now 1 over 0.7782, that's 1.2850 plus 1. This is equal to 2.2850. So this is my answer. At the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 5 to the power of x plus 2 is equal to 4 to the power of x. So the first thing I'm going to do is I'm going to take the ln on both sides, or natural log. So now I have ln 5 to the power of x plus 2 is equal to ln 4 to the power of x. Now, if I have something in the form ln a to the power of b, I can actually move this exponent of b to the front. So this is going to equal b times ln a. So for ln 5 to the power of x plus 2, I can move x plus 2 to the front. So that's going to equal x plus 2 times ln 5, which is equal to, for ln 4 to the power of x, I can move x to the front. So it's going to be x times ln 4. Now, if I distribute ln 5 with x plus 2, I get x times ln 5 plus 2 times ln 5 is equal to x times ln 4. Now, I'm going to subtract both sides by x times ln 4. So now I have x times ln 5 minus x times ln 4 plus 2 times ln 5 is equal to 0. Now if I subtract 2 times ln 5 on both sides, these two cancel out. Now I'm left with x times ln 5 minus x times ln 4 is equal to negative 2 times ln 5. So now if I factor out x from x times ln 5 minus x times ln 4, I get x times ln 5 minus ln 4 is equal to negative 2 times ln 5. Now, if I have something in the form ln a minus ln b, this is the same thing as ln a over b. So ln 5 minus ln 4, that's going to equal ln 5 over 4. So I have this is equal to negative 2 times ln 5. Now I can move this negative 2 to the front of the 5. So now I have x times ln 5 over 4 is equal to ln 5 to the power of negative 2. Now 5 to the power of negative 2, that's the same thing as 1 over 25. So now this is equal to ln 1 over 25. Now if I divide both sides by ln 5 over 4, these two cancel out, and now I'm left with x is equal to ln 1 over 25 over ln 5 over 4. So this is my answer. Alright, so in this video, I'm going to solve the problem 500 squared minus 499 squared. So, to solve this, what I'm first going to do is rewrite this as 499 plus 1 squared minus 499 squared. And if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. So 499 plus 1 squared is turned into 499 squared plus 2 times 499 times 1 plus 1 squared, and I have this minus 499 squared. Now I can cancel out 499 squared and negative 499 squared, so I'll be left with 2 times 499 times 1 plus 1 squared. 2 times 499 is 998, times 1 is just 998, and I have this plus 1 squared, which is plus 1, and this is equal to 999. Now I actually have another method of solving this. So I have 500 squared minus 499 squared, and this time I'm going to rewrite this as 500 squared minus 500 minus 1 squared. Now, if I have something in the form a minus b squared, this is equal to a minus b times a minus b, which is equal to, if I factor this out, a squared minus 2ab plus b squared. So this is going to turn into 500 squared minus 500 squared minus 2 times 500 times 1 plus b squared, which is 1 squared. So these two cancel out. However, this is actually going to be in parentheses. So the negative sign distributes. So this turns into 500 squared minus 500 squared plus 2 times 500 times 1, which is the same thing as 2 times 500, minus 1 squared. Now these two can cancel out, so I get 1,000 minus 1, which is equal to 999. So again, I get 999 as my answer.